Hey, good morning, everybody. We're going to, this is the first week we're going to try this new format where I'm doing pre-recorded sessions instead of going live, just to kind of cut down on the distractions. My children would be behind me jumping around right now going bananas if this were live. So we're going to give this a shot, see how it works out. It's a very short set of notes this week and not too many assignments as well. One of them is going to be extra credit. So we'll go over that. And the other thing is this is the first set of notes that we're going to go over that will lead into um, a second set the same week. So later this week on Friday, we'll be introducing another set of notes going into more detail on respiration, and that's kind of leading us into a short week next week where we're only going to have two sessions, well, 2 days, one session for you guys. So I want to make sure that we kind of get ahead of the curve here. So let me shrink this down and we'll get started with this rather short set of notes. So we're starting module 4. It's on cell respiration. And as we go through the module, you'll notice that this set of notes is pretty short. I think it's only like 9 slides long. So the next set will be a little bit longer, a little bit more detailed. So we're starting module 4, lesson 1. You can see the learning objectives on this page, and it is also in Canvas, so you can take a look at that on your own. All right, so this is a lesson on respiration overview, and we're going to be basically kind of introducing respiration in this lesson and then going into a lot more detail with the second lesson that we will start on Friday. All right, so a quick introduction. The conservation of energy states that energy is neither created nor is it destroyed. It just changes from one form to another. One example of the transformation of energy is during the process of photosynthesis, when the plant converts sunlight to glucose. And this transformation of light energy into chemical energy, once this transformation has taken place, the plants and other organisms are able to further convert that energy into a usable form, ATP specifically. This rearrangement of chemical elements to form energy molecules happens inside all living things, and it's known as cellular respiration, as you're going to see as we go through these next couple lessons. So, what is the chemical equation for respiration? It's going to look very familiar to you guys, and I'm going to move myself real quick so I'm not in the way, but it's going to look very familiar to you guys because it's basically the opposite of photosynthesis. So if you take the products of photosynthesis and switch it over to the reactant side, and the reactants of photosynthesis and switch it over to the product side, you have cellular respiration. So one of the defining characteristics of all living things is that they need to obtain and use energy to survive. Every living thing on Earth accomplishes this task by the process of cellular respiration. Now, there's a few organisms that kind of cut this short and do something called fermentation, but that's a conversation for another time. The chemical formula for cellular respiration is glucose, okay, along with 6 molecules of oxygen. So here's your glucose, here's your oxygen, is going to make 6 molecules of carbon dioxide, 6 molecules of water, and energy. And the energy here is going to be ATP, or adenosine triphosphate. So this formula is basically read how I just read it. Sugar, or glucose, and oxygen react to create carbon dioxide, water, and a little bit of energy. The energy is in form of a molecule called adenosine triphosphate, or simply ATP. This molecule is basically the energy currency of all living things. And if you remember a couple lessons ago, I think I mentioned you can think of ATP and glucose as energy molecules, and glucose would be a higher denomination molecule, so it would be, like a $20 bill, and then ATP would be smaller denominations, or think of it as $1 bills, right? So if you take that $20 bill, that glucose molecule, and break it down, you're going to get 20 singles that you can use for various things, okay? So all living things use ATP as an energy molecule. Cell respiration allows for the chemical elements of sugar in the presence of oxygen to be rearranged into ATP, thus giving organisms the energy it needs to survive. Few important background pieces of information that you should be aware of. And again, let me move myself so I'm a little bit more out of the way. Maybe shrink myself a little bit more here. So there's a few important details about cell respiration that must be understood before taking a deeper look. That's why we're kind of breaking this set of notes into two sections, and this is a very short section to introduce it to you, okay? So sugar is broken down in the presence of oxygen to form energy in the form of ATP. Part of the reaction takes place in the cytoplasm, and that part happens in the mitochondria. Um, so you got one part kind of happening before it gets into the mitochondria, and then the second part happens inside the mitochondria. All living things perform cellular respiration. Water and carbon dioxide are byproducts of the reaction, and then cellular respiration is different from breathing respiration, which is the exchange of gas in the blood. So, how does respiration work? Below, there's a simulation activity, and I'm going to point that out to you in a moment. And this is going to be where you can get some extra credit, guys. So if your grade is suffering, this is a easy way to get some extra credit. Not a whole lot to do with it. You click through a simulation found on Canvas, and then just write me like a little one-page report on what you did. Okay. So there's a simulation that you'll be required to go through step by step. This will give you a better understanding of how organisms are able to bring in reactants of sugar and oxygen and chemically change those into energy, carbon dioxide, and water. While you're going through the simulation, pay attention to how the results of the experiment are being measured. So recall the balanced equation we talked about was glucose, oxygen, carbon dioxide, making carbon dioxide, water, and energy, and that will kind of help you as you go through that simulation. Here's the link for the simulation. There's also a link on Canvas, so it's probably easier to click on the link on Canvas, but I might click on this one and just kind of show you what it's going to look like. So go through each of the steps of the activity below. This includes the introduction, the key concepts, all 6 exercises. It's found at this link, and then once you go through all those steps, come back, go to the section that talks about the extra credit, and you can either write right in a text box or you can write it on a Google Docs and submit it that way. But basically, about one page talking about what you did and how the simulation went. Okay, so let me click on this and we'll take a look real quick. So when you click on that link in Canvas, it's going to take you to a section that looks like this. It says Lab 5 Cell Respiration. You can click through the key concepts and so on. Go through the introduction, click on each of these, and that will kind of take you to sub areas that you can go and take a look and get definitions and so on. So once you're kind of get used to going through all of this, you'll simply click through, look at the key concepts. So you can click on respiration, click on photosynthesis. You can go to the next step and so on. So I'm not going to go through all of it for you guys, but you can kind of take a look. You can type in answers. At the end, I believe there's a little quiz that you can take and so on. So you can play these animations, which kind of shows you what's going on. It's a cool little interactive simulated lab. Okay, so again, kind of a cool little thing. And then once you're done, if you write that one page little summary of what you experienced and turn that in, you can get 50 extra credit points. Okay, all right. So let's go ahead and we'll finish this up. The last thing I want to tell you is all your work for the week. Make sure you do all the self checks. I think there's 2 or 3 of them for Module 4, Lesson 1. Watch the videos. There might be one, and then again, it says ungraded, but it's actually graded as extra credit. So an ungraded assignment, if you do this assignment and write a short 1-page report, you can earn some extra credit. If you got an A in the class and you don't want to, you're busy with other classes, don't worry about doing this. You don't have to do this. It's not going to count against you. It can only help your grade. And then the only graded assignment we have this week is going to be a little quiz. It's going to be a 24-pointer. However, I'm kind of doing it like the self-check quizzes where you can do it multiple times and it's worth 24 points. So another opportunity, because you can take it as many times as you wish and everybody should get 100 points. It's another opportunity to kind of boost your grade with that 24-point quiz point that you can get. All right, guys. So that's it for today. Kind of short. And when you're doing this lesson in class, I will be telling you probably beforehand, once you're done watching this video, which should only take 10-15 minutes or whatever it ends up being, and go ahead and start those assignments or do that extra credit assignment. So you're getting some extra time in class to kind of do those. Once again, thank you. Have a good day, and hopefully this pre-recorded lesson works out for us.